Life and evidence of life is all around us. From the smallest of bacteria to the largest of blue whales, it exists in many forms. What's truly extraordinary is that all of these forms of life call Earth its home. The vastness of the universe has led people for centuries to look up at the night sky and wonder, are we truly alone? Or is there other life out there looking up from a distant planet wondering the same thing? That is why, in mid-April, a certain discovery sparked global attention. And with a little more research, the search for life beyond Earth could progress like never before. On April 16th, the New York Times, along with many scientific journals, announced the discovery of the most convincing and credible evidence of life on an exoplanet to date. 120 light-years away, exoplanet K2-18b orbits a red dwarf star in the constellation Leo. Since 2015, this exoplanet had been looking pretty promising for hosting life, as its atmosphere is rich with hydrogen, methane, and other carbon compounds, as discovered by scientists analyzing the light emitted from it. Last month, however, the James Webb Telescope picked up another signal from the planet, a light signature providing evidence of the compounds dimethyl sulfide and dimethyl disulfide. And this was what was most exciting. The signal was so strong that scientists have concluded these compounds to be thousands of times more present on K2-18b than on Earth. Here, on Earth, dimethyl sulfide can mean only one thing: evidence of marine algae. If dimethyl sulfide is found in the atmosphere of K2-18b, we could be looking at life on another planet. So, why is this compound linked so closely with these organisms? Dimethyl sulfide is a byproduct of metabolism in algae. This means that when other molecules are broken down to release energy by the algae, dimethyl sulfide is released. Recent research has also found evidence that this compound plays a role in cloud formation once it's in the air. It can also help regulate the climate. When people talk about the search for life anywhere, you will most likely hear the term biosignature. And that's what dimethyl sulfide is, a piece of evidence that indicates the presence of life. However, biosignatures can come in many different forms. The first being spectroscopy, and this is what happened with the light from K2-18b. This is when a telescope, in this case the James Webb Telescope, captures the light that bounces off a planet's surface or atmosphere, or the light produced by the heat of the planet itself. And I just want to put out a reminder that there is a huge spectrum of light beyond what we can see. This ranges from infrared to ultraviolet. So, when light shines through different gases, such as the gas form of dimethyl sulfide, different wavelengths of light are more present than others due to the chemical composition of the gas. So, this is the graph of showing the different elements and compounds present in the atmosphere of K2-18b due to what wavelengths were produced from this planet and captured by the James Webb Telescope. Scientists also look for morphological evidence of life. This includes fossils and a thing called stromatolites. These are also known as microbiomates and can be living or fossilized. This is when microorganisms die off and create structured layers of minerals. Chemical biosignatures are another way scientists look for life. They especially look for the evidence of lipids, carbohydrates, nucleic acids, and proteins. They don't, however, look for DNA or RNA because they don't know if organisms on other planets store information like that. They also look for how macromolecules are shaped. Are they right or left-handed? You might have learned about this in chemistry class. For example, proteins are right-handed, simple sugars are left-handed. They also look for the ratio of isotopes of chemical elements. Life as we know it here prefers lighter isotopes. These are elements with less neutrons, and they use these for chemical reactions and catalysis of those chemical reactions. The final way, and the way most likely found in the movies of how scientists look for life, is the transmission of messages from extraterrestrials, and this would include television and radio waves. So, this discovery on K2-18b has led me to wonder, what does searching for life on other planets mean for humanity itself? What does some marine algae trillions of miles away mean to us? I think it means progress, and progress in the sense that we have advanced science such that we're not just looking up at the sky and waiting for a message from the aliens, but scientists are putting in the work and finding evidence for something we never thought possible.